All right, let's finish up the last three. All right, so these are some kind of interesting ones. All right, and so I thought I'd save them for the last little group. All right, so the first one is kind of like a problem we saw a while ago. And we're going to split the fraction. All right, so we have the integral of x plus, oh, there's no dx here. I knew something was missing. Dx is missing. Excuse me, not x plus 5, just x. All right, so anytime you don't like the fraction you got because you're like, what the heck do I do with the plus 5 part, split it into 2. So we have x divided by 4 minus x squared dx. All right, and then plus the integral of 5 over 4 minus x squared dx. And let's go ahead and factor out that 5, because I think it'll make that one easier. So we have, oops, and don't forget the radical. All right, and so now we have the integral of x over 4 minus the square root of 4 minus x squared dx plus 5 over the integral of 1 over the square root of 4 minus x squared. So we saw one like this, but was with one that was an arctan. Well, this one is an arcsine. So if you've got that pattern, perfect square, anything that can be written as a perfect square, minus perfect square, and you've got something that you don't really want in the numerator. Come on. There we go. Split fraction in 2. Apparently my tape decided to just pause. All right, so now we're good on the first one is a u to u substitution. The second one is good. All right, so on the first one, u is going to be the stuff in the radical, 4 minus x squared. And actually, we should probably rewrite that. So why don't we rewrite that right now? It'll just make it easy later. X times 4 minus x squared to the negative 1/2 power. And we've seen that one. We just haven't seen it put together like this. Here, I'll just move that down. There we go. All right, and then du is negative 2x dx. We've got the x, but not the negative 2. So just divide by negative 2. So negative 1/2 du equals x dx. All right, so this will be replaced with a negative 1/2 du. And this will be replaced with a u, and the exponent stays. The other one is good. All right, so we have negative 1/2 times the integral of u to the negative 1/2 du, and then plus 5 times 1 over, and I'm going to rewrite this part though as 2 squared, minus x squared. And now we can just integrate that. That'll be negative 1/2 u, and that will be negative 1/2 plus 1 would be to the 1/2. Divide by the same thing. This is really similar to one we did, except for this part. Plus 5 times arcsine, and it'll be x over 2 plus c. Let's just substitute back, and this one is done. Actually, let's simplify, and then this one will be done after we rewrite it. So negative 1/2 times 2 times u to the 1/2 plus 5 arcsine x over 2 plus c, and that's going to be negative 1/2. Excuse me, negative 1. So we have f of x equals negative, we'll substitute back, so negative square root of 4 minus x squared plus 5 arcsine x over 2 plus c. There we go. So sometimes if it looks unfamiliar, just look and see if we've done something like it, or you can rewrite it to be something like it. In this case, we could split the fraction. All right, so this one is really a unique one. We haven't done one like this, and I don't know if you'd recognize it right off the bat. But let's change. So initially, it looks like we should make u be 1 plus e to the 2x. But if u is 1 plus e to the 2x, I don't have the derivative of e to the 2x, which is 2e to the 2x. And I can't do anything about, coefficients, no problem. But I can't do anything about the exponent. However, if we make it instead u be, this is a unique one, e to the x, right? So that means du is e to the x dx. So this part up here is du. The 1 stays. So you might think, oh, wait, is that the u? No, this is the u. This will be u squared, right? Because e to the 2x is the same as e to the x squared, right? And so we're just replacing the e to the x part, right? So that's what I told you. So it's a little unique. So, and let's change the limits of integration too. So we'll rewrite this and we'll change the limits of integration. So this will be du on top, and then 1 plus u squared. And I hope you recognize it now. All right, so the limits of integration, if x equals negative natural log of 2, I guess that's a negative. I don't know why I didn't just make it natural log of 2. Actually, you know what? Let's just make it natural log of 2, because I'm not 100% sure that negative goes there. And I couldn't find it in my notes whether it's supposed to be a negative. Let's just make it natural log of 2. We'll get rid of the negative. So if x equals natural log of 2, then u equals, u was e to the x, so u equals e to the natural log of 2. Oh, I didn't want the negative. I did want the smaller number in the bottom. Never mind. Never mind. That's why the negative's there. Not that it has to be the smaller number, but I like it better that way. If x equals negative natural log of 2, then u equals e to the negative natural log of 2, and that's just negative 2. If x equals 0, then u equals e to the 0, which is 1. All right, so we'll change our limits of integration to negative 2 and 1. And I still feel like we're going to have an issue when we go to evaluate. That's why I'm not sure if something was missing off this one. We had that random 1/4 floating around. All right, so let's integrate and let's see how bad it is. And we'll just evaluate it the best we can. The integrating is super easy. That's just going to be arctan. All right, so this is, and this would be 1 over a, but a is 1. So it's just arctan u. And we're evaluating that from 1 to negative 2. And now is the icky part, because where is tangent negative 2? I don't know. It's not a pretty number. We should have made it a pretty number. Maybe I should change that one to a nice pretty number. Let's see. Oh, let's make that. Let's just change that to square root of 3. Just so that we can have something nice to plug into and not have to leave it sitting there as the arctan of negative 2, which is not a pretty number. All right, so if that's what I didn't like about this problem, just my limits. If x equals negative natural log of square root of 3, then u equals e to the negative natural log of square root of 3, and that will be negative square root of 3. And the rest is fine. So now we have a much nicer number. That we could actually evaluate. All right, so let's draw it over here. Arctan lives in the first and fourth quadrants. So 1, 1, square root of 2. This is pi 4. It's just the 45, 45, 90. All right, so this one, the other one, so when we plug in, we're going to have arctan, I should plug in first, 1 minus arctan negative square root of 3. Right? So arctan is 1 at pi fourths. And arctan is negative square root of 3. All right, so that would be down here. All right, so the opposite would be the negative square root of 3, and the adjacent would be 1, and this would be 2. All right, and so this would be pi thirds, but that'd be negative pi thirds, right? Because we're going in the negative direction. So negative pi thirds. Right, and we can add those together. So that would be pi, let's make it twelfths. So 3 pi twelfths plus third is 4. 4 pi twelfths makes that 7 pi twelfths. There we go. And we're done with that one. And we have one last one. And this one, so if the numerator of a fraction has the larger degree, try long division. So we're going to do long division. I might try and do it really quick. All right, so x minus 1. And don't forget to represent missing values. We are missing some values here. So x cubed plus 3x squared plus, actually missing 1, 5x plus 0. You have to multiply x by x squared to get x cubed, so x cubed minus x squared. Subtraction means to add the opposite. That would be 4x squared. Bring down the plus 5x, and you have to multiply x by 4x. 4x times x would be 4x squared. 4x times negative 1 is negative 4x, and subtraction means to add the opposite. That's going to be 9x, and we'll bring down the plus 0, and you'd have to multiply x by 9. 9 times x would be 9x. 9 times negative 1 would be negative 9, and subtraction means to add the opposite. That'll be 9. So now rewritten, this will be the integral of, and we haven't done anything to we haven't done any use substitution. We've just changed the format, so it's still 1 to 2, and that would be x squared dx plus the integral from 1 to 2 of, and actually we can just make this 1. I don't think we really need to split it up. Plus 4x plus 9, and then plus 9 over x minus 1 dx. Let's integrate and evaluate. All right, so this one won't be too long. I thought it was going to be longer than it really is going to be. So this will be x cubed divided by 3 plus 4x squared divided by 2 plus 9x. This one isn't plus 9. I wasn't really thinking about my limits of integration. 1 minus 1, no problem. Let's just, that was never 1. It was 2 and 3. You hear me? 2 and 3. You never saw 1. That's what happens if you make them up. X, and you don't check it first. X cubed divided by 3 plus 4x squared divided by 2 plus 9x plus 9 natural log of x minus 1. You can see why 1 was a problem. And then that's evaluated from 2 to 3. Let's reduce. So x cubed divided by 3 plus 2x squared plus 9x plus 9 natural log of x minus 1. And let's evaluate it up here where I have a little bit of space. So that's going to be, plug it in 3 cubed divided by 3 plus 2 times 3 squared plus 9 times 3 plus 9 natural log of, shadow's blocking here, and we don't really need the absolute values, 3 minus 1. 1, 2, 3, 4. Yeah, we got everybody. And then all of this, we're going to subtract with a 1, or a 2. 2 cubed divided by 3 plus 2 times 2 squared plus 9 times 2 plus 9 times natural log of 2 minus 1. All right, so that's going to be 27 divided by 3, that's 9, plus 3 squared is 9 times 2 is 18, plus 27, 9 times 3, plus 9 times the natural log of 2, which we're going to be stuck with that, and then minus, I guess I like pluses a lot, 2 cubed divided by 3, so that would be 8/3, plus 2 squared, 4 times 2 is 8, plus 18, yep, and then plus 9 times natural log of 1, right? And what do you have to raise e to get 1? That's 0, right? So this whole thing here is big old fat 0. And so now let's simplify. All right, so we have 27 plus 27, 54, plus 9 natural log of 2. And then, oops, this is 1/3. And then 26, and then plus 8/3. Oh, excuse me, we're subtracting. Ooh, never mind that. So be careful about your negative. Minus 8/3 minus 26, right? We're subtracting that part. Right, so I'm trying to squeeze it in here. 54 minus 26 is going to be 28. So 28 and minus 8/3 plus 9 natural log of 2 equals, all right, so 28 is, I have no calculator over here. Hang on. Wait, that would be 60. Right, 60 times 80, 84, right? Yes, 84. All right, so 84/3 minus 8/3 plus 9 natural log of 2 is going to give us a final answer of 76/3 plus 9 natural log of 2. There we go. There's the answer, the exact answer. All right, so a few steps involved, the easiest of which was the integration. Right? Computation takes the longest. Right? But just be careful when you're computing, and be careful with your parentheses and negative. And that's going to be the end of this podcast. So thanks for watching. Bye for now.